All right, so today we're going to be looking at how you can build 2D and 3D geological models within Geosoft's target environment. The seminar today is going to demonstrate how you can enhance your subsurface insight by visualizing drill hole and borehole geology data and integrate this quickly with your surface geology, geophysics, and geochemical data. I'm now going to introduce our presenter for today, Kathleen Matthews. Kathleen is a solutions consultant at Geosoft with over 10 years of experience working in the mining and petroleum industries. Kathleen has a BSc in geology from Dalhousie University and has worked in petrophysics, exploration geology, and provided consulting services in geological technology and data management. Kathleen will take you through how to use Geosoft target tools and workflows to show how you can simplify your visualization and enhance the analysis of your drill hole data. Please welcome Kathleen Matthews.
Good afternoon, everyone. Thank you for joining us today. As Lorraine has already said, Target provides a complete solution for your exploration geology, enabling you to visualize and manage your drilling data and conduct integrated analysis of surface and subsurface geochemistry, geophysics, and geology in 2D and 3D. Just to let you know that Target is available also as a drill hole extension with our Oasis montage platform and as an extension in ArcGIS called Target for ArcGIS. But today we're going to demonstrate Target standalone. Today I'll demonstrate a typical workflow. First I'll display geochemical and geophysical data within surface mapping. I'll import and view our drill hole data. We'll display our drill hole data within plan maps, sections, fence diagrams, and strip logs. We'll also look at explicit modeling using creating 2D interpretations that can be used in 3D to create geological models. And we'll also create some 3D volumes and isosurfaces. So the first step is to take a look at some geophysical and geochemical data within surface mapping. So to load your geophysical data, you would access that through the database menu and import. And there's several different types of file formats that you can import. There are three toolbars and three menus to take note of in Target. Surface mapping, which is where we'll create our surface maps. DH data, which is where you manage all of your drill hole information and create your projects and import your data. And DH plot is where you create your sections and plan maps to display your drill hole data. So under surface mapping, there are also other options you can add to your maps, such as survey lines, symbols. You can also conduct some gridding. There's minimum curvature and kriging options here. I've already created a map here that's displaying a meg grid in the background. It's also displaying your geochemical samples as point symbols, and we have contours at 150 meg values. You can also display your survey paths, and if you notice at the left, you can turn on and off your layers under the View Group Manager, and this option is available for all of your mapping. The databases that were created and loaded under the database menu exist here as well. We have our MAG database and geochemical database. You can see that the databases look like an Excel spreadsheet, but there are some added functionalities in here as well. If you right-click and list, you can see all of your lines for your MAG survey. And also you can display a profile for your MAG data at the bottom. And you can do some editing as well. Okay, the next step is to create a drill hole project and to import your data. Under the DH data menu, this is where you would create your new project, and it's also where you would import all of your data. You can see the options here. If I were to select, if I were to select a database, a file to load in here, we have a wizard that allows you to load all of your drill hole information, and the database looks the same. It's like an Excel spreadsheet. Once you have all of your data loaded, your drill hole data loaded, there is a QC tool in here as well, where you can select the data type that you want to QC. If I select from to, selected holes, I'll run it on all holes. It will run a report, And it will open it up in your default text editor and tell you if there are any issues. And many of these issues are not critical, but you have the option of seeing what they are, and you can go back and correct it in your databases. There's also a compositing tool under DH Data. You have the option of choosing your input assay. You name your output, selected holes or all holes, and decide the interval selection here. And I've already created a composite database here with gold and arsenic values. Once you're happy with your drill hole data, you can now display this data in plan maps or sections. And once you've created some sections, then you're ready to create some 2D geological interpretations. So the first step is to create a plan map, but you likely don't want to plot every drill hole on your plan map, so you can choose a subset. Under DH Plot, there is a selection tool which allows you to easily select the holes that you want to display. To plot anything, it's under the DH Plot menu, select Plan Map, and there's a lot of options for data that can be displayed. In this case, we're plotting our collars color based on the bottom depth. We're also going to display our hole traces, and we have different options for data. In this case, we're just displaying our geology along our hole traces. If I zoom in to the plan map, you can see your colored collars based on bottom depth, hole traces, and the geology along your hole traces. And everything is also output in the legend. Next, we'll create a fence diagram. And again, you select this from the DH Plot. And a fence diagram is used to compare your downhole geology for several drill holes at a time. You also have the option of the data, and we're just going to display our geology between our holes. And in every parameters window, you have similar tabs for page layout, collars. You can select a topography grid. And this is what your fence diagram will look like. If I zoom out, you can see a plan view of the holes that have been selected. Another option is to display your data on a strip log. You can display up to 32 data elements on your strip log, and you can choose to display it for one hole or a range of holes. And if you select a range of holes, it will create an individual strip log for each one of those. On the Data tab, I'm displaying the geology, the gold assay values, gold values from our composite database, and arsenic assay values. So here's our strip log. And you can also identify these significant intervals here by using the compositing tool. And just take note that anything that you have open, whether it's a map or a database, is listed under Project Explorer. See databases, maps. Any map you can select, and the options will be displayed above, and you can turn those layers on and off. The next step is to display your drill hole information in a cross-section. Under DH Plot, you can select section and the parameters window opens. Under Plan View, we can choose to display a plan map showing your section location. And also we can display several different types of data. In this case, we're going to display our gold composite values, our geology. And the third option we're actually displaying gold values that have been gridded using the minimum curvature method. To draw your section, you would go under the Section Location tab, click Define. It'll go back to your plan map, and you can actually draw a box around the section you want to create, and that information will be stored. So this is the section that was created. Plan map above, geology along the hole traces, and minimum curvature goal values in between. The next step would be to start creating some geological interpretations. Explicit, and that's referred to as explicit modeling. Explicit modeling in Target allows you to build 3D models from your 2D geological interpretations. The first step is to create a series of sections displaying your geology. Next, you will manually digitize your 2D interpretations, and then you can open these interpretations in 3D where wireframing is used to create your models. So I've already created some sections. In order to create your interpretation, you need to access the GeoString toolbar. You would select New GeoString. You would name it. Verify your coordinate system, and then you can add a feature. Choose whether it's a polyline or a polygon, and a description. And this is saved to a GeoString database. I'm just going to open an existing one. And you can see my interpretations are displayed on my sections. There's a polygon for alluvium, and then the top of an iron formation. And I'm going to add the iron formation to this section. First step is to select your feature. Make sure you're using the snapping tool, and we're snapping to our geology database. And then you're going to digitize. You'll notice that there's a halo and a red circle around the cursor to let you know it's snapping. There are right-click, and there's options to undo and correct. Once you've created that interpretation, it's saved into your geodatabase. We can now open this interpretation in 3D environment and create some 3D models. To access 3D functionality, there's a 3D menu. You can create a new 3D view from scratch, or if you have an existing one, you can open it. I have an existing one, and I'm going to open it. You'll notice on the left side, any layers that you're adding to your 3D will be listed here, and you can turn them on and off. In this case, I have a topography grid displayed, and I also have geology displayed along my hole traces. In order to create your 3D models, you would access the wireframing menu. When you click Start Wireframing, you'd select your GeoString and your feature, and go OK, and you'll see them displayed. So you can see the interpretations we created on our sections are now displayed in 3D. And the feature that we're about to wireframe is highlighted in yellow, and it can be selected and joined to create your 3D body. And once you open your GeoStream database, it's permanently listed at the left, and it's a layer that can be turned on and off. The wireframing tools window is also open, and you can save your wireframes as a geosurface file. Okay. You can also just create voxels and isosurfaces in your 3D environment, and this is referred to as implicit modeling. Unlike explicit modeling, implicit modeling uses mathematical algorithms to automatically create the volumes and isosurfaces. Voxels are referred to as 3D gridding. To create your voxel, you can access the voxel menu, and we're going to create a lithology voxel. I've already created one here, and it goes through everything in your geology database and will create your voxel in your 3D view. If you want to see the volume, you can click on Visible Cell Statistics, and you can see the volume listed there. There's also clipping options along the X, Y, and Z. We can also create a voxel from our existing gold assay values. And we're going to clip it based on a topography grid. We've selected the top grid here. You can also select a bottom one. If I display the topo, you can see it's clipped to that grid. Isosurfaces are 3D contours, and we're going to extract these from our gold assay values as well. Under Add to 3D, you select Isosurface, and you can create multiples. You choose the input voxel and the name, and you can specify the values for these isosurfaces. So now we can see our isosurfaces displayed here. Value of 1.25 and 2. You can adjust the transparency on these. Once you've created isosurfaces, you can actually export these to an AutoCAD DXF by selecting them. You can also create horizontal and vertical slices from your voxels. So we're going to add to this 3D section grid extracted from our voxel, and we're going to do this from our map. And you can see your slice displayed. Another useful utility in here is called 3D PDF. If you want to share your information here from your 3D viewer with a non-target user, you can export it to 3D PDF. 3D PDF comes with your target installation. You can zoom in and out, and it also maintains the rotational ability. Today we have shown you how you can manage and visualize your drill hole data, how to visualize it in 2D through sections and maps, how to digitize your geological interpretations that can be used to create 3D geological models. We have also shown you how to create voxels and isosurfaces from your data in 3D. I highly recommend that you visit our website, www.geosoft.com, for more information, including information on workflows, how-to documents, and videos. And we'll take some questions now.
Thank you, Kathleen. So we will take your questions, so if you can take a moment to type them in if you haven't already done so, then Kathleen will review those and start answering them. And while you're answering, I'll just remind everyone that the capabilities and workflows that Kathleen showed today are available in the most current release of Target version 8.2. We have recorded today's seminar, and we will include that linked in follow-up, and also the answers to the questions that Kathleen will be taking shortly.
Okay, we have a question here on how to create a long non-vertical section. We refer to that as a longitudinal section in Target. I'll just close the viewer here. I've already created one. So this allows you can actually filter out your geology and mask your geology to just isolate one particular rock type. And once you've done that, you can create a section just displaying that rock type for all of your drill holes. And you would do that in the same way you create other sections. Once you've masked out your geology and just selected one, you can use your section location tab, change your swing value, and then you can define it. And again, it goes back to your original plan map to do that. Okay, let me see what other questions are here. Okay, let's see. Okay, someone asked about measuring volumes in 3D. I'll just bring up 3D viewer again. I'll display one of the voxels here. And then you would click on, with your voxel layer turned on and selected, select visible cell statistics. And you can see your volume here. How do I display isosurfaces on a 2D section? Again, I'll open the 3D viewer. Turn off this voxel. So we already have isosurfaces here, and it's a geosurface file. We can export that to a DXF. And then you go back to the section. Whoops. And under slices, you select that DXF file. And I displayed some isosurfaces on this longitudinal section here. That's what the pink is. Those are all the questions right now, but anything that has all the questions that have been recorded, questions and answers will be sent to you after this.
All right. We'd like to thank everyone for joining us today, and if you do have any further questions you'd like to answer, or if you'd like to try an evaluation license of Target yourself, please do contact us at our info@geosoft.com address, and we'll get back to you right away. So we'd like to thank everyone for coming out today and joining us for today's seminar.